Hello again, algebra students. Welcome back. Today we're going to talk about slope of a line. You've already learned about slope last year. We need a refresher on it, but it shouldn't be a brand new idea for you. Slope, we talk about it in a lot of different ways. It can be talked about like the rate of change between 2 points on a line or in any kind of a situation. It's also measuring the steepness of a line and the direction of a line, if it's going uphill or if it's going downhill. So when we're finding slope, we're going to find, it says the ratio, but that just means it's going to be a fraction, the change in y over the change in x. So change in y goes on the top, change in x goes on the bottom. This picture, personally, I hate the way that they draw this because I don't want you to be thinking about going sideways first and up and down. As we're looking at slope, I always want to go from left to right. So if I'm starting at this point right here, I'm going to go up 1, 2, 3. I know they've got the 3 right there also. And that's this number right here. And then I'm going to go sideways, 2. Change in y is the up and down, change in x is the sideways, so this is going to be 3 over 2. I just don't like it when they draw it over here where it looks like you should be going sideways first like you do with ordered pairs. The one thing that's confusing about slope, in my opinion, is that as we've been graphing ordered pairs, we graph the x first and then the y. So we go sideways, then we go up and down. Slope reverses it. We go up and down first, and then we go sideways. So again, several different ways here to look at slope. We use the letter M for slope. And again, hopefully you remember that from last year. M is, slope is going to be that ratio, change in y over the change in x. So we can look at it in terms of, if we're just counting slope, we would use this right here, rise of a run. We count how much you go up and down, you count how much you go sideways. Change in y over the change in x is just kind of a general what happens all the time. And then this is the actual slope formula that, again, I'm hoping that once you see it, you recognize it from last year. The change in y is really just subtracting the y values, and then the change in x is subtracting the x values. Those little subscripts, like the little bitty 2 down here and the 1 that's right there, those are subscripts. Instead of an exponent, it's a subscript, so it's lower instead of above. And when we're reading it, we're going to say things like x sub 1 or y sub 2. It's just an organization thing. It's not a mathematical thing. You don't have to do anything with the 1s and 2s other than just use it to keep it organized. When we look at graphs of slope, we've got a positive slope graph here and a negative slope. As we go from left to right, the same way that you read, the same way that you write, we're going to go from left to right. So this graph is going uphill. So that's a positive slope. And again, going from left to right, this is going downhill. I know that some people get confused and they say, well, if you go the other way, if you go from right to left, then it looks like that negative slope is really going uphill. We want to always go left to right. You should recognize Mr. Slope Guy, I hope. Mr. Slope Guy helps us to remember all the different kinds of slopes. So when we look at Mr. Slope Guy's eyes, this eye is a plus for positive. That's what a positive slope looks like. Again, left to right, it's going uphill. This is a negative slope. It's going downhill, left to right. His mouth, this horizontal line, has a 0 slope. That's what those dimples are. And a vertical line, his nose, is an undefined slope. That's why we use the U under there to make it look like a nose and to remind you that it's undefined. So if I am taking a look at letter A, hopefully, after that review, you remember now this is really a positive slope. It's going uphill. I'm going to count the slope, but we also have the slope formula all figured out right here. So they have those numbers on there. I just told you I kind of hate how they draw it like that. So I would go from this point that's on the left, I'm going to go up 1, 2, 3, 4, 5, and that's that same number right there. And then 1, 2, 3, 4, 5, 6. So my slope, I know right now, remember M is for slope, my slope is going to be up 5 and over 6. That's what my answer is going to be. It is a positive slope. It's going uphill. When I take those two ordered pairs and I substitute them into the slope formula, so we had -3, -1, and I kind of wrote over +3, +4, but I have them right here also. They have these all labeled with X's and Y's and X's and Y's. Remember, so I know that it's listed right here next to it, but I'm going to write it over here too. This is an X, this is a Y. That's what happens for every ordered pair. The X goes first and the Y goes second. So we're going to call these our ones because it's our first ordered pair. And these are an X and a Y, but these are my second ordered pair. Now, all I have to do is put those numbers in the right place in this formula. I want to subtract the Y's on the top, and I have to go in the same order for the top part and the bottom part of the fraction. So the Y sub 2 that's been labeled now, this is going to be a 4. I'm going to uncover it in just a second. The Y sub 1 that was labeled was a -1. Now you have to be careful here because it's going to be 4 minus a -1. You know we're going to want to change that. And then in the denominator, I don't know if I'll be able to write this under here, but X sub 2 was 3 minus, and then X sub 1 is -3. So again, I would keep change. So on the top, I'm going to get a 5. On the bottom, I'm going to get a 6, which is what we got from counting. Okay, so you can find the slope with the slope formula or with counting if you have it graphed. If I don't have it graphed, I'm not going to take the time to graph it. I'm going to use the slope formula. Now, I want you to notice this thing right here. We happen to label the first order pair with the 1s and the second order pair with the 2s, just because it was the first order pair and the second order pair. If I had told you the order pairs in the reverse order, if I had said 3, 4 was my first order pair, I could do all the same work and get exactly the same answer. So if I switched these to 1s and these to 2s, now my Y sub 2 is a -1. My Y sub 1 is 4, and we're subtracting, remember. My X sub 2 is -3 minus my X sub 1 is +3. If I do this, I'm going to get -5 over -6. And you guys know, two negatives are going to make a positive. I'm going to get the same answer. So it truly does not matter which order pair you have as your 1s and which order pair you have as your 2s. Now, taking a look at the second example. This one is going downhill. It's going to have a negative slope. You can already see that they've got stuff labeled here, but if I would count this, I would be moving down 1, 2, 3. Remember, I always want to go from left to right, and over 2. So my slope is going to be down 3 over 2. When I take those two ordered pairs that they have there and substitute it into the slope formula. This time I'm not going to write all over it, but you can see what's labeled for your X1 and your Y1 and your X2 and your Y2. Substitute all those numbers in there. So the Y sub 2 is -2 minus +1. And then my X sub 2 is 1 minus my X sub 1 is -1. So I would take that and do a keep change. That's going to give me -3 over 2, which is what we have also. Okay, I don't really care if the negative is out in front of the whole thing or with the numerator. We don't tend to leave it in the denominator, but it's not wrong to have it there. So again, if you have a graph, don't bother labeling all of your points. You're going to count your slope. The problem with this one is, what I don't like, is that they're counting by 3s on the y-axis, and they're counting by 1s on the x-axis. So if you do this and you count 1, 2, 1, 2, 3, you think that your slope is 2/3, but it's not. This is really going from 3 up to 9. That's really going up 6 units. And to go from -1 over to +2, that's over 3 units. So my slope is really 6 over 3, which is 2. Doesn't look like a slope of 2, but that's what we have to be careful about when we see graphs like that. Number 2, they do just count by 1s. So I can just count my normal slope. This one is going downhill, so I'm going to move down. 1, 2, 3, 4. So my slope is going to be down 4, and then sideways. 1, 2, 3, 4, 5, 6. That does simplify though. If we have slopes that can simplify, please simplify it. That's going to be negative 2 over 3 when I divide both of them by 2. What that tells me also, since that did simplify, there should be a point in between my 2 points that was nice. If I would go down 2 and over 3, 1, 2, 1, 2, 3, right there, I hit another really nice point, and then I could do the same thing. 1, 2, 1, 2, 3. The thing about slope is that it's a constant rate of change. If you have a straight line, it doesn't matter which points you choose, you're going to get the same slope between those points every time. Now, the easy way to do this one is thinking about Mr. Slope Guy. That horizontal line, that's like Mr. Slope Guy's mouth. This has a slope of 0. I can tell you that right now without showing any work. I can also show the work. I can also substitute stuff in here. So if I would take this 5 minus this 5, and hopefully some of you remember seeing it like this last year, subtracting the y's on the top, 5 minus 5, and then 6 minus negative 1, that's what I have listed in here. The denominator is going to be 7, but the numerator is going to be 0. 0 on the top is going to give me 0 for my answer. And here's the other option that we have besides positive, negative, 0 slopes. This is like Mr. Slope Guy's nose, which is going to be an undefined slope. So if I subtract these y's on the top and the x's on the bottom, so I would do 6 minus that 2 and then 4 minus that 4. 6 minus 2 is 4 on the top, but 4 minus 4 is a 0 on the bottom. I can't have a denominator of 0 ever. That's an undefined fraction, also an undefined slope. So again, that's Mr. Slope Guy's nose. It's an undefined slope. So here's just a quick reminder then. So we've got a positive slope and negative slope. 0 slope is horizontal. Undefined slope is vertical. Feel free to pause that and write any of those down that you want to. Here is, I think, the harder part, right? Counting slope from graphs probably came back to you pretty quickly. Finding the slope, that slope formula is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I know that some people kind of freak out about that formula. Guys, it's just 2 subtractions. You subtract the y's, you subtract the x's, okay? I'm going to do one of these that same normal way that we did with the regular formula, and then I'm going to show you kind of a shortcut way that I just kind of did already. In each ordered pair, I'm going to say this is an x and here's a y. X's are always first, y's are always second. We'll just make these my 1s since it's my first ordered pair and these are my 2's. So substituting into my formula, y sub 2 is negative 18 minus y sub 1 is negative 12. X sub 2 on the bottom is 16 and x sub 1 is also 16. Right there, that should tell you that there's an issue with this one. The numerator is going to be a negative 6. The denominator, though, is 0. This is undefined. By the way, undefined is not a no solution. You can't just use the 0 with a slash through it. You have to say that it's undefined. I'm okay with my students stopping right there, undef. But you can't just use a U. It's not Mr. Slope Guy's nose. You have to actually communicate with us. On number 6, I want to find the slope. You can do it exactly the same way that I just did number 5. Labeling all the x's and y's and 1s and 2s, and that's fine. Personally, here's my shortcut, and I kind of did it on the horizontal one that we just did before. If I know that I have to subtract my y's and they have to go on the top, I'm going to draw a line that connects my y's above the 2 ordered pairs, and I have to subtract my x's and they have to go on the bottom. So I'm going to draw a line that connects the x's on the bottom. If I do that, instead of labeling everything, and I can certainly go back and label if you'd like, but I would have a y minus a y is going to be 12 minus 9. Since I started with my 12, since I started right here, I have to start right here. I have to start with the same ordered pair both times. So I would have negative 3 minus negative 5. Don't forget that that's still minus a negative. We're going to do a keep, change, change. So on the top, 12 minus 9 is just 3. On the bottom, negative 3 plus 5 is 2. 3 over 2. Doesn't simplify. However, do not change that into a mixed number. Don't give me a decimal. I don't want 1.5 or 1.5. Slope is a ratio. It's the change in y over the change in x. Like when we're counting slope, we want to know how far we're going up and down, how far we're going sideways. So personally, I really like that shortcut a little bit better than labeling all of my x's and y's and ones and twos. But you have to remember that the y's go on the top and the x's go on the bottom. So this time I'm going to start with this ordered pair. Just because I've told you we can use either one, I can look at these numbers and I know it's going to be a little easier this way. So I'm going to have the 4 as my first y, 4 minus the negative 1. And then since I started with the 4, I'm going to start with the negative 9 minus the negative 12. Keep change. So I get 5 over 3. And again, don't change that into a mixed number or a decimal. Some students really like to do every single slope problem the same way. They always want to have the first order pairs as their ones and the second order pairs their twos, and you can absolutely do that. I personally don't always do that because sometimes it's easier to do the math in a different order. So if I'm looking at those two numbers, before I even draw my line for my x's, I like to have negatives as the second part of my subtraction. Like I would prefer to have 7 minus a negative 13. Doesn't really help me in the denominator, I know, but I like that because I know that I'll do a keep change. Then for my x's, since I started with the 7, I have to start with the 3 minus 17. So I'm going to do a keep change on both, and I'm going to get 20 on the top, and on the bottom, 3 plus a negative 17 is going to be a negative 14. So the negatives in the denominator doesn't really matter. It's still going to be a negative answer. And I can simplify this. I could divide them both by 2 and get 10 over 7. So today you're doing the worksheet in your packet, a riddle worksheet. It's called the Duckworth Steels. Part of it is counting slope, and then the other part is using the slope formula. Please try to use that slope formula. Do not just go back to a graph and graph them and count. I want you practicing that slope formula. I promise it'll save you time in the long run. When you're done, there's an answer key in Schoology, and take the formative quiz. Let me know if you have any questions.